Hi guys, I'm David, and this is my show Almost Daily Science, where we talk about the most interesting science news and research articles that come to my attention. So today we're going to talk about several articles. We're going to start with this one from phys.org that says the Nanophotonics Orchestra presents Twisting to the Light of Nanoparticles. So that's pretty fancy, but it's a really interesting article, and I'm excited to share it with you. So it's talking about physics research from the University of Bath in the UK, where they discovered that a new physical effect relating to the interactions between light and twisted materials. And the basic idea is, so they start off the article, which I've linked below, talking about the nature of sound. So the article is about light, but we're starting off with sound. And what they point out is that musical instruments make more than just a single pure note, but every musical instrument has a unique timbre, which is also known as the tone color or tone quality. All instruments have a timbre. When a musical note with a specific frequency is played, the instrument creates harmonics. So these are frequencies that are an integer multiple of the initial frequency. For instance, the primary note has a specific frequency, like 500 hertz. That would be 500 cycles per second, for instance. And then there's harmonics that are generated, which would be double, triple, quadruple, quintuple, etc. And those notes play simultaneously. And different instruments actually have a different collection of harmonics. What's really interesting, and I did not know, is that the same thing is true for light. So similarly, when light of a certain color with a frequency that designated Fc shines on materials, these materials can produce harmonics. So light frequencies with double, triple, quadruple, etc. And so the object produces not just the specific color, but also these frequencies. And that's super interesting. One of the things that jumped out to me immediately when I first read this was also, though, that given the relatively narrow wavelength range that the human eye can actually see and the brain can interpret, I imagine that most of these frequencies are probably invisible to human eyes. And in fact, it says, for instance, virtually every green laser pointer is in fact an infrared laser pointer whose light is invisible to human eyes. The green light that we see is actually the second harmonic of the infrared laser pointer, and it's produced by a special crystal inside the pointer. And that's pretty interesting. Going on, and we're starting to sort of build the case towards why this is actually scientifically important, beyond just being interesting. In both musical instruments and shiny materials, some frequencies are forbidden. That is, they cannot be heard or seen because the instrument or material actively cancels them. So they bring up the clarinet, and apparently because the clarinet is straight and cylindrical, it suppresses all the even harmonics, so the double, quadruple, etc., and produces only odd harmonics, and that gives it a specific tone quality. Then they say, by contrast, the saxophone has a conical and curved shape, which allows all the harmonics and results in a richer, smoother sound. It's not really obvious to me why a straight cylindrical shape would suppress the even harmonics, but that's probably something that's easy to find out if you were wanting to read about it more. They say, somewhat similarly, when a specific type of light, so circularized polarized light, shines on metal nanoparticles dispersed in a liquid, the odd harmonics of light cannot propagate along the direction of light travel, and the corresponding colors are forbidden. Interesting. So the same thing is true for metal nanoparticles dispersed in a liquid. The odd harmonics are forbidden. And that gets us to kind of the crux of the application for this technology, is that they say now an international team of scientists led by researchers from the Department of Physics at the University of Bath have found a way to reveal the forbidden colors, amounting to the discovery of a new physical effect. Okay, so basically what they're saying is, by careful application of light waves to an object and then measuring the harmonics that are coming off of that, they can actually use this as a new way to identify the shape of objects at the nanoscale. Interesting. So they say our study opens up the study of the harmonic signatures of these twisted molecules, such as DNA, amino acids, proteins, sugars, etc., so we can appreciate their timbre for the first time. In other words, this gives us a new way to characterize nanomaterials. And they think this is going to have some implications in terms of nanotechnology applications in communications, nanorobotics, and ultra-thin optical components. So the third article that I want to look at today is a little bit less controversial, or maybe it's more controversial, depending on your viewpoint. And it says, this is an opinion article from the 19th of September, and it says, astronomers should be willing to look closer at weird objects in the sky. And I think we're talking about things like UFOs, for instance. So the Galileo project seeks to train telescopes on unidentified aerial phenomena. So things that are in the sky that we just don't know what they are. Maybe we catch them on our iPhone and we upload them to a conspiracy website, or, you know, we call into Coast to Coast AM. I don't know if they still have that show. So starts off, and this article I want to point out is actually by someone who is, let's see, who's it by? Okay, so the article is by Avi Loeb, who's the former chair of the astronomy department at Harvard University. So he knows whereof he speaks. So he says, when purchasing a new phone or tablet, it's a common practice to select the best technology that fits your needs within the available budget. And this is also the strategy adopted by our research team at the Galileo Project, a new initiative to image unidentified aerial phenomena, UAP. Why can't they just call them UFOs? That's what I want to know. So he says, to my amusement, I recently came across an online retailer that would allow us to add to cart a 1-meter telescope for $500,000. Fortunately, cheaper telescopes are all that is needed for surveying the sky at the proper resolution to identify UAPs. So he goes on to say that basically they need a certain telescope diameter on the order of 10 centimeters to be able to resolve things that are the size of a cell phone from 10 kilometers away. And then the idea is that instead of having a big telescope, you know, that's much bigger than that and can really identify or really have very good resolution, they would rather have several medium-sized telescopes with these like 10 centimeter size. And this would allow us to monitor the motion of objects in 3 dimensions. So they would be able to see, you know, the same object from different angles with different telescopes. They said the telescopes could be supplemented by a radar system that would distinguish a physical object in the sky from a weather pattern or a mirage. Now here's a critical point. They say, and I'm just going to say UFOs because it's more fun. So he says UAPs, but if UFOs are solid objects, they should heat up as they rub against air at high speed. The surfaces of objects that move in air faster than sound, such as supersonic airplanes or space rockets, are heated by hundreds of degrees. I calculated that the infrared glow of fast objects above a meter in size, supplemented by the heat from shock waves in the air around them or an engine they carry, should be detectable with infrared sensors on telescopes out to the desired distance. So that's a fundamental assumption in viewing these UFOs. So they say the data from a system of optical, so that's visible light, infrared, or radio telescopes will be fed to state-of-the-art video cameras linked to software that will filter out objects of interest for the telescope to track. So, okay, so they ignored everything that looked like a drone or a bird. He says, my student Amir Siraj and I calculated the number of UFOs described in the report corresponds to about 1 object per 100,000 square kilometers per year. This is well below the rate of unidentified objects from cell phone photographs or civilian eyewitness testimonies, implying that many of these unofficial sightings may have mundane explanations. Careful wording. They say millions of cell phones with millimeter-sized apertures are inferior to what Galileo proposes. a much smaller number of optimized telescope systems with apertures 100 times larger that are designed to rapidly track unidentified aerial phenomenon. But overall, he's proposing that we be as open-minded as possible and actually take the time to look at these weird phenomena some more. So I appreciate that perspective, especially because of the initial assumption that he made when he said earlier, he said if UAPs, or I'm calling them, if UFOs are solid objects, they should heat up as they rub against air at high speed. And then they should have a certain infrared or heat profile associated with that. But that's assuming, of course, a UFO enthusiast, which I am not, but if I was a UFO enthusiast, the way I would wiggle out of this one is I would say, aha, but Professor, you're assuming that the UFO doesn't have some state-of-the-art alien technology which prevents or vastly reduces friction from the air. So, presumably the alien technology has a super advanced coating which allows their spaceships to enter the atmosphere or leave the atmosphere very rapidly without burning up on re-entry, like our spaceships do if they go in too fast or without the right sort of coating. So that would be maybe the one flaw in its reasoning. But overall, it's a pretty interesting article, and I'm excited to hear that there's projects like this where astronomers are kind of open-minded enough to actually look at the weird objects in the sky. It's a really good point overall, just about the camera apertures of cell phones, that they're a couple millimeters compared to a really legit telescope is going to have a diameter of 10 centimeters or more to be able to resolve small objects from a long distance. So just in general, if you get various artifacts and phenomena on your cell phone, weird things that don't look right, it could just be the fact that the camera is just, I'm looking at my phone, the camera is just really, really small. Anyway, this is a very interesting article and I recommend you read it. I have the link below. Thanks again for watching. I hope you enjoyed this science update. You can see all the links to the articles I discussed down in the video description below, and I hope you'll join me again in the future, maybe tomorrow. Bye.